Okay, so now what we're going to look at is when we have sort of polynomials of these trig functions. They're usually a little bit easier to recognize than the ones that we saw in the exponential chapter. But really, it would be the same trick. What we might want to do is apply some kind of, apply some kind of substitution so that it looks like maybe a cleaner polynomial on our part. So I've got a 2 sine squared theta minus sine theta minus 1 equals 0. So I can recognize that this is a polynomial of sines because I've got a sine and a sine squared term. So what I might want to do is actually swap out y equals sine theta. And then my equation becomes 2y squared minus y minus 1 equals 0. And now that's just a normal polynomial that we solve using traditional techniques. We factor. You can do that straight from what's written above, but maybe it's harder for you to see if you've got all those signs in there. So, all right, I'm going to factor this. This should factor to a 2y and a 1 and a y and a 1. And it's just a matter of figuring out where the negatives go. I need the 2 to be negative to make the middle negative. The other one should be positive, so it multiplies to minus 1. This should hopefully check out for you. And so yeah, we get 2y plus 1 times y minus 1 equals 0. And so we have y equals negative 1/2 and y equals 1. So that's not our answer. We do need to go and put the substitution back in. And so our answers will be sine theta is negative 1/2 and sine theta equals 1. So for the sine theta equals negative 1/2, that's going to be my cast rule. I want sine to be negative, so it's got to happen on the bottom. So I draw my bow tie triangles. I want them to at least look the same. And I have negative 1 over 2 for my opposite, or my y over the hypotenuse. And yeah, it's just going to be grabbing which triangle that looks like. If I do the third side, I should have root 3 and negative root 3. That's my 30, 60, 90. And yeah, so opposite of the 1 should be 30 degrees in there. And I want all the answers between 0 and 2 pi. So I do want to make sure that I wrap around the correct way for that. It should go in the positive direction. So I can't cheat and go down negative because it's not in the right solution set. I'm going to have to go down like this and then around like that. So the second one's 360 minus 30 and the other one's 180 plus 30. So we should have from this 210 or 7 pi over 6. And this one's 330, which is 11 pi over 6. I'm missing my 11. Okay, so that's part of it. I also need the sine theta equals 1. I mentioned before that when the answer is 1, it doesn't really make a nice triangle. So what I'm going to do instead is look at the graph of the sine function. And so my graph, I know sine starts at 0 and goes up, down, up. And we want where sine theta equals 1. That's going to be right here. That's a height of 1. So this is sine theta equals 1. If we use some of the symmetry of the graph, this is 360 or 2 pi. And this would be 180 or pi. And that's halfway through. So that tells me that my theta should be 90 degrees or pi over 2. And that should be the only answer in between specifically the 0 to 2 pi interval that we're interested in. There's more outside of there, but we don't want those. And so my complete answer set for this region is going to be 7 pi over 6, 11 pi over 6. I keep just turning my 11 into pi. 11 pi over 6 and pi over 2. Right, we'll do one more of these. Okay, for a second one, we'll combine some of the concepts in the previous sections, and then I have a slightly different angle that we're going to be solving for here. So solve for all theta in R, but specifically I want it in degrees. So that's all real number thetas, and we can leave our answer in degrees. So our equation is 8 cos squared plus 9 equals 18 cos squared. Same as before, we've got that cos and cos squared. So I'm going to do my substitution. I'm going to let y equal cos theta. And so what I'll get is 8y squared plus 9 equals 18 cos theta. Sorry, y. I'm making that change. That's the whole point. Same thing. It's still a quadratic equation. We should still be able to solve this thing. So we do that by factoring. I'm going to bring the 18y to the left. And then we've got to use factoring techniques to get through this. I need two numbers that add up to negative 18 and two numbers that multiply to the product of 8 and 9. Yeah, so to find these, we're going to rip through the pairs of 72 and just find the one that gives us 18. Because it is a positive 72, we do know that the two things have to have the same sign, which means they both will be negative. So we do want a sum of 18, but two negatives adding up to negative 18. So yeah, my numbers, if I go through this, 1 and 72, 2 and I'll use a comma in between them. 2 and 36, getting closer, but still pretty far. 3 and 24. 4 and 18. 5 does not go into it. 6 and 12, that should be the one. So negative 6 and negative 12. And so if you remember what we do with that for this factoring, 8y squared minus 6y minus 12y plus 9 equals 0. And so we do our partial factoring here. 2y I can take out from there. And then I get 4y minus 3. And then minus, I should be able to take out 3. And then if I've done this correctly, the other bracket is the same. Yeah, we get that. Looks good. And then bring the 4y minus 3 out. And we're left with 2y minus 3. And so we have y equals 3 over 2 and y equals 3 over 4. And so if I sub the coses back in, that should give me cos theta is 3 over 2 and cos theta is 3 over 4. And so solving this one, this has no solutions. So remember that cos theta is trapped between negative 1 and 1. 3 over 2 is too big. It's bigger than 1. So that one doesn't work. So we don't get any solutions from that chunk. But the 3 over 4 is okay. So yeah, so I've got this 3 over 4. Cos is positive. So I set up my cast. And it should go on the right side. And so I'll set up my triangles. So 3, the hypotenuse is going to be 4 for both of those. What you might be noticing is that this is not a special triangle. So those special triangles aren't going to help me. So what we can do in this case is just use a calculator. I can find the third side. It should be root 7. Yeah, 16 minus 9 and negative root 7. But yeah, it's not fitting into those special triangles. So we're going to have to use a different method here. So we're going to use the calculator to get our reference angle. You can actually use the calculator to get the reference anytime, the reference angle anytime. It's just that you really do want to be familiar with those other triangles. Some of you might not actually be able to use a calculator in the future, so your answers will usually fall in these nice triangles, but in this particular case does not, so we can't use them. I'll use my reference angle. We want to use the positive values to use the to get the reference angle. So just use absolute values. In this case, we could just use the positive triangle, which is fine. So my theta r, what I'll do is use the cosine for theta r. So cos theta r, just use positive values adjacent over 4. They are positive already, but just even if you have negatives in there, use the positives. So this tells me that my reference angle is 41.4 degrees. And so I should be able to get the second angle by going around like that. That will be 360 minus 41.4. Or I could actually just use the negative. Why don't I do that? Since we're doing all real answers, it doesn't really matter which initial one I choose. We just need 2 of them in a circle. So the other one I'll have is negative 41.4 degrees. And then all we need to do is do all of the answers in a circle. That's going to mean using the periodicity of the function. So include all the other solutions. That's just a plus k times 360. And so that K360 is specifically what is going to give us the rest of our solutions there. So I can make that arrow a little bit more clear exactly where those are going. Yeah, but we need that for the all possible solutions. Yeah, so I just wanted to do one example where we weren't able to use the special triangles.